Okay, we're about 2 minutes after. We'll go ahead and get started here. I want to thank everybody for joining us today. As you can see, we're going to be talking about things that go wrong in the industry, whatever kind of generation you might have. In this case, it's a pretty nasty looking one where a blade broke. So the question is, does this ever happen to you? Anybody out in the plants who've been doing generation over the years knows it has happened. So we want to get into and talk about preventing disasters using predictive analytics. And I'm again, I'd like to welcome you here. My name is Evan Seacock. I'm your host today. I'm the director of NERC compliance here with Surtrac, and our main presenter is Greg Wolf. He's president, CEO of Fisher Block. Very creative person here, I'll say. He came up with a neat device, which I think is really neat, and then it can definitely help people prevent disasters down the road. So going through, went through our introductions, talk about some challenges. How Fisher Block and Surtrac are working together to help with predictive analytics, and then how predictive analytics can help with challenges, use case, the ease of installation, which is a real biggie, and then of course fault recording and some other functions within our compliance. We'll go through conclusions and then questions and answers, and would appreciate folks to go ahead and hold their questions to the end. But you can also, we'll be able to go talk about asking questions and over the mic, and also can put them into the question format. You can put in information and we'll be able to answer those questions for you. And here at Surtrac, we're focusing on multiple things for the power generation. Again, it doesn't really matter what your fuel is, wind, solar, gas, nuclear, whatever it might be. We do a lot of work with compliance type work using SaaS applications and various services. Today, we're going to be focusing on digitization. That's really what Fisher Block is doing. It's actually giving a lot of information and converting analog type signals to digital signals that can then be processed and looked at for helping folks understand what may be going wrong with their equipment out in the field, and then also looking at cybersecurity for utilities. Of course, we want to help generators be more reliable for the grid, and that's really what NERC's all about, is to have a reliable grid. And then a big part of that is via SaaS application and technology to help reduce the risk of non-compliance for GOs and GOPs. And again, here in a minute, Greg will get into it, but he'll be going into talk about what Fisher Block's been doing, what they have, their devices, how it can help. You can see it from wind, it can help, which is generation. Again, any kind of generation. It can help in transmission, so it's not just limited to generation, transmission, distribution, and then also all the various components, electric motors, whatever you might have for pumps within your plants themselves. And can get into some of our challenges that have been faced by utilities, and it's been various changes throughout the industry. Definitely a reliability, trying to get down the road with NERC, reliability, availability, and efficiency. Well, reliability also gets into cost. If you're down, whatever, from a generation standpoint, or even in a manufacturing standpoint, you want to be reliable and know that your equipment's going to be there so that you can get your product out the door. Again, could be widgets or it could be power. It doesn't really matter. So with that, you need to understand the health of your equipment, and so you're trying to get some information in to help you with that. And then also, which if you have no idea what's going on in your plant and you have to bring down your plant, maintenance costs are there, and so you lose productivity and the cost of repair. So unplanned equipment failures cause operational downtimes, like we said. Risk of equipment adds additional costs, but it could also mess up your product stream. Depending on what kind of manufacturing you might have, you may have a lot of product that gets stuck in, say, piping or something, which you don't want, because that's additional costs to clean that out possibly. And maybe there's some times to clean out those pipes for product hardens. And then inefficient ability to monitor the plant operations. It's just, if you're not sure what's going on, you don't know what's going on. Obviously statement. And of course, we get into the lack of visibility can have an increased restoration time. If you don't know what's going on, you're going to increase those. Limited staff also can increase the times for restoration because you just don't have the overall staff. And trying to get information ahead of time you know, it will help you out. And of course, everybody's knowledge is going out the door with, like myself, I'm an older folks. So eventually I'll go out the door, and we need something to replace that with. And that's what we'll be getting into more, especially with the official blocks. So how to overcome the challenges. So our person there is super AI man there. He's holding up the world. He's holding up your plant. And so want to use that to the best of our abilities. You know, analytics is a huge resource that is now being tapped, and it can provide all sorts of information, you know, from an early warning alerts, can't speak today, protect against unwanted surprises. You know, your equipment's starting to fail, you may not know it, but predictive analytics can definitely help you out. You know, and one of these things, Greg, and you may have seen some of this in your, you know, time that you've been doing this, you know, it can help reduce shutdowns by 45%. You know, we have looking at this in a lot of countries. So y'all are in a lot of countries. There's a lot of generation out there in the world. Anytime that you can help prevent an unplanned outage is a huge benefit. Of course, our management always wants the reliability of the system to be there. You want availability and you want efficiency, and you know, availability, efficiency definitely help with those goals. And then, of course, from a NERC compliance standpoint, we want to help make sure that generation and transmission and distribution, all the folks are meeting their compliance goals. It also helps reduce reliance on spreadsheets when you have the system that Greg and his team have put together, and also, you know, helping with going through search rec. All this will help get you more data. It can be overwhelming, it may seem like, but in the end, the way it's set up, it ends up being alarms where you don't have to go through and figure out a lot of stuff. It's actually just information. And then, of course, it just helps, you know, streamline your overall system. You know, and I guess, you know, Greg, that was probably your thought when you were coming up with some of this with AI. If let you give some background on this too from your standpoint.
Yeah, sure. Thank you. And I really appreciate the opportunity to discuss and provide an overview of our technology. And we're focused on providing visibility in a way that is very unique. There's traditional ways of collecting data on your assets and your system, primarily in the form of SCADA systems and Pi historians and so forth. What we're doing, though, is we're monitoring the electrical signals in the process, whether it be generation or delivery across a grid or consumption. And we're looking at how the electrical signals are impacted by the degradation of the assets, so that in rotating equipment, for example, as subcomponents begin to degrade in health, such as windings or bearings or gears or fan blades, they will start to actually impact the electrical signal. And if you're able to monitor the electrical signal in very high resolution, which is what our technology does, and I'm talking several thousand samples per second, we're actually monitoring that sine wave through its complete cycle. And we're looking for subtle distortions that are that occur at certain frequencies that we can then associate to various aspects of the assets in the process. And then our device there on the left, a smart block, is what we connect to the control panels. And then the smart blocks are communicating with our software application, Wave IQ, which is doing all of the post-processing and archiving and comparing to the data to a larger population. And then Wave IQ communicates back to the smart blocks with what it's learned, and then can update the smart blocks configuration as to what to look for, what conditions of interest are worth sending back to Wave IQ. So it's very much a closed loop system. And then providing then the solution being predictive analytics and warning operators of the systems of situations that are out of the norm, and well in advance of an urgent situation. Our goal is to provide information and insight well in advance of when you have to take action, so that way maintenance can be planned in a proactive manner. So that's the solution that we have, and we have some use cases that we're going to go through today that I'm very much looking forward to. And so here's a breakout, kind of exploded view of a wind turbine generator. And what we do is we're monitoring the electrical signals, as I said, and we're able to then, through the electrical signal, monitor the electrical system and aspects as well as the mechanical components. And then we have user-friendly dashboards area at the top right that provide an indication that things are going from green to yellow and then yellow to red. And there's several dashboards that we have that are tailored to various applications.
So essentially, with what we were showing there, that you're saying that you can determine possible issues all the way through, from the motor through a transmission there, all the way out to the blades, based on feedback that you're getting off the wave IQ.
That's right. It's interesting because a wind turbine, the blades are rotating at approximately 1/4 hertz once every 4 seconds. And then as you get into the gearbox, the first pinion is a sun gear that's rotating a little bit faster. It's about 10 times fast. So it's about 4 hertz. And then you get into the planetary carrier, which is operating at about 6 hertz. And then you're into the mid range, and it just goes all the way down into the generator, which is then at about typically 20 hertz. And then if it's a 3-pole pair generator, then that's 3 times 20 is 60, and that's the 60 hertz out to the grid. But interestingly, that sun pinion is a recent use case. I think we're going to possibly talk about that later in this presentation, but we noticed a distortion not too long ago monitoring wind turbines, and we noticed a 4 hertz distortion of about 0.1 or 0.2% of the total 60 hertz signal out to the grid. And consulting with the OEM of the gearbox, we confirmed the sun pinions operating at 4 hertz. They went in and did a borescope inspection, and sure enough, found a crack in the sun pinion gear. And so it's very interesting how mechanical components, if we know their operating frequency, we can then on the front side associate them and immediately looking at the electrical signal, know where to go inspect. Over time, with some older assets where we may not have the nameplate information, there's a feedback in terms of what we find in inspection and feeding that back into the platform, so that going forward, then there's not a lot of question as to what's causing the distortions. And really, it's frequency extraction, FFTs, DFTs, pulling the frequency components out of the time series signal, and then providing a platform to track them over time against an asset's own history and an asset's versus its sister assets. And so it's not just rotating equipment, it's also transformers, breakers, capacitor banks, lightning arresters, so forth. So it's very interesting technology, we think. As I said, it's a situation where monitoring the electrical signals, we're able to ascertain the health of the electrical systems. As you can see there, relay performance, breaker trip times, as well as the mechanical aspects of the assets as well. Those operating frequencies of those mechanical components distorting the electrical signal. And so it's very interesting tracking and monitoring both electrical and mechanical components. So it makes that's a very unique differentiator compared to a vibration sensing system or temperature, which is pretty much mechanical related.
So yeah, so what you're saying also is that it's good for looking at pumps. So we saw sort of an example with that when we talked about the wind turbines, right? So this could be also can be applied to pumps, issues with pumps and plants. Whatever. Anything that a motor is turning, the feedback it can sense. Okay.
That's right. That's right. Alignment issues is common in pumps and motors and
Yeah.
all that distorts the electrical signal in consistent ways. And so here's an example of, it's not rotating equipment. This is out on the grid in a substation. This was a substation where the customer actually didn't even have waveform capture when a breaker tripped. And so whether it's electromechanical relays or microprocessor relays, our solution is a added benefit and value in terms of 24/7 waveform capture. Even if a breaker's not tripping, if something's out of the norm, where we're seeing maybe voltage fluctuations or transients, phase imbalances that may not trip a breaker, we're capturing that. And in this particular situation, though, customer was having, or our customer, the utility, was experiencing what they call nuisance trips, where randomly, it seemed random, they weren't sure why it was happening, but they were getting breaker trips and then voltage sags on other buses and other problems on other feeders. And so they weren't sure why it was happening and where it started and so forth. So we implemented our solution. We installed, I guess, 38 devices. No outage required. Our sensors there are very unique in that they can be installed without an outage and with no new wiring. In that situation, we install our devices as retrofit covers onto Flexi style test switches. And so taking the dust cover off, putting our device on with 2 thumb screws, we have ruggedized pins, making contact with the phase voltages. And then we have a hollowed out bolt where we run an insulated cable through to the back, and we snap on split core CTs over the secondary wiring. So no disruption to the wiring, no outage. It's about a 10-minute installation per device. And within a 10-day period, we had captured our first breaker trip and how it propagated throughout the substation, because our devices are all talking to each other as well. So the first one that triggered captured its waveform on that bus and feeder, and it also sent a digital pulse to all of the 37 sister devices, and they all have a circular buffer, so they have some history that's preserved. And so they all triggered at the same time. They all captured their various buses and feeder signals, and our Wave IQ platform renders all of those ComTrade formatted charts on one time axis. So the user can then scroll down and look at all 40 waveforms in this case and see which one started, how it propagated, and it's just new visibility that just has not been available in the market. And here's a picture of, on the left there, what I just mentioned a minute ago, where we have an insulated cable. I don't know if you can see my mouse, but it's coming through the bolt on the test switch to the back. And then we terminate that cable with a small connector in the tray there. And then we plug into our split core, 3-phase split core CT assembly. That those CTs are hinged, so they open and they snap around the secondary wiring there. We also have installations where we mount our device right to the back of test switches there. So on the right there is the behind a panel view. It's a different substation than we looked at a minute ago. But we don't need hollowed out bolts in that case. We'll mount our device right to the back of the test switch. So we don't need any additional real estate on the panel in these cases. We do have alternate brackets. We don't need to connect to a Flexi style test switch. We can mount directly to a panel, either magnetic mount or to a bracket with 2 studs that we provide. And we also have adapters to other types of test switches and test blocks and relays back in the rear of a relay as well.
So in my days of dealing with design of these things and putting in like digital fault recorders, the big difference with here is that you're not having to run wires all the way from your CT circuits, PT circuits down to a digital fault recorder, right? You're doing it all right here and then transmitting that information either a digital signal or wirelessly. Is that correct?
That's right. It's like distributed fault recorder in a sense. And yeah, we'll communicate typically through Ethernet. That device there, I don't see an Ethernet cable. However, we have a Ethernet jack in our device. Each one of our devices has an IP address. So it's communicating, traditional TCP/IP to a server, which can be in the substation, running WaveIQ behind, the enterprise firewall, or the server can be remote, still behind the customer's firewall, but at a remote location. So you don't require any type of a server in the substation, or it can actually route to any server outside the network, which could be Fisher Block servers for some of our customers, with servers in-house that we have, and we also have a cloud platform running on AWS. And then through the Certrec portal as well. So yeah, here's another case where it's rotating equipment that we're monitoring 24/7. And we have scheduled scans where the smart block device is monitoring the various loads, environmental conditions, and will do time series waveform captures and then process that data through a frequency extraction algorithm to monitor then the various frequencies to ascertain the health of the subcomponents that we talked about earlier. And so this case, the motor's operating off 60 hertz, which is the fundamental frequency there in the center of that chart. However, it was developing rotor bar problems where there was a hot spot or some type of degradation on the rotor connection, the winding connections. And that manifests itself as sidebands on the fundamental, plus or minus a small frequency amount. And that frequency is basically a function of the slip frequency, which is the difference between the rotational speed of the asset versus the grid speed. So that slip frequency then, plus or minus that frequency, is where our software looks around the fundamental. And as those sidebands grow, and a certain amount is normal. However, when they start growing in magnitude, that means that that those rotor bar imperfections are getting worse. And so there's thresholds that industry kind of looks for in terms of portable equipment. Over the years, portable equipment has been used in certain cases. And so there's established thresholds. However, our software also establishes those thresholds based on statistics and specific asset related characteristics. And what's important here though as well is the noise floor, because as those sidebands start growing, the lower the noise floor, which is really dynamic range of the monitoring system, the lower that noise floor, that means the earlier our software can start tracking these sidebands that are growing in height, and they grow over weeks and months. And so the lower the noise floor, the more time the maintenance group has to plan for an ultimate inspection or a repair. And then so we trend that over time. And so extrapolating that trend line, they can see, okay, in 6 months, we need to, at that time, be in there to do an inspection. So it's very much supporting a proactive maintenance process. Okay, and in this case, they found cracked rotor bars when they went in there.
So this is using fast Fourier analysis type, you said time domain, to be able to get the sensitivity that you need. What is the sample rate of the device? The smart block there. What's it sampling at?
Right. We're sampling upwards of 128 samples per cycle. What's interesting is the faster you sample, that means then obviously it's intuitive that you can then understand that you can see higher frequency components. But interestingly, the longer you sample before you do your frequency FFT, the longer that data set in time means the higher the resolution you get on the chart. And so it's a combination of sample rate and duration of sampling. And those two kind of work against each other, because the higher the sample rate and the longer you sample, the data set becomes bigger. And then you need more storage and bigger bandwidth. So it's a trade-off, and so we actually adjust our sample rate and our duration of samples based on the application, and we'll do multiple versions of each on a given asset. And another example here is a characteristic. This is an FFT as well, where we noticed very interesting spectral components at multiples of generator or rotor speed, and they grow in height as the harmonic components show up, and that's a classic signature of a misalignment or an alignment problem. And so that's what, at that time, this was a few years ago, our software was alerting this as an alignment issue. And when they went in and did the inspection, they actually found a pinched rotor cable that was arcing with the rotation of the rotor. And so that information now has been fed back into Wave IQ. And so now when our system sees that type of a signature, it warns of a potential alignment issue or a pinched cable arcing issue. And so it's an example of the feedback loop, but this is a situation where it could have been catastrophic if that arcing ended up creating a fire or some type of a violent condition. Another example here. Okay, so this is one that's not a rotating asset that we looked at here a minute ago, but it's rather a item out on the grid in substations. I'm sure a lot of the audience here has heard of the term capacitor bank and what that is. For those of you that are not aware, in order to maximize efficiency of energy delivery, it's best that the voltage sine wave and the current sine wave are actually synchronized in time. So you really want, like, when your volts at a peak is when you want your current at a peak. You don't want them to be delayed in time. And then likewise, when one of the voltage sine wave, when it crosses zero, you would want your current to be crossing zero at that same time. Otherwise, you're getting two zero crossings at different times. One's volts, one's current. And each time one crosses zero, the power is zero, because power is volts times current. So if those zero crossings aren't lined up, then you're having twice as many zero crossings. Your power is going to zero twice as often. And that's just an example of why you want volts and current to line up. However, most of the assets on the grid are, let's say, inductive in nature, like a motor windings, for example. Motors consume half of all electrical generation in the world, approximately. And so motors, though, with all those windings in there that are consuming massive amounts of current, they actually cause a delay, a time offset between volts and current, which puts a burden on the utilities to generate their voltage in sync with current when their large industrial customers are forcing this offset. And so utilities and even industrial plants will install capacitor banks to actually offset that time voltage and bring that back into synchronization. And they do that by these automated capacitor banks that bring capacitance into the circuit and they take it out when it's not needed. Well, you want to switch capacitor banks in and out at a zero crossing when there's no current flow and no voltage. Right at the instant of a zero crossing is when you want to bring the cap banks in and out. If you don't do that at a zero crossing, then you're getting these contacts closing and opening when there's a high voltage, and that can cause arcing inside the cap banks. And eventually that will cause a cap bank to fail. And so our software then is monitoring these signals, and when there's we see transients near zero crossings that are slowly over time migrating away from a zero crossing, then we know the timer inside that cap bank controller is getting worse and worse, and we then alert on that. And in this case, we're seeing transients in excess of 40,000 volts, and they end up taking action before it completely failed. But then once we see this, then our software gets smarter to where we start alerting earlier. And so this is a great example of value proposition on a non-rotating asset. And another one here leading up to, and this has absolutely no moving parts at all. We saw for many hours, and I'm not sure, maybe even days, transients in the RMS signal that ultimately led to a breaker trip. And it was a failing lightning arrestor. And you can see there when the breaker tripped, that fault actually lasted about 30 cycles, it looks like. And I recall that customer was concerned that 30 cycles was excessive. That ideally you would want your relay to trip the breaker in, very short period of time, so that all the assets in the system are not subjected to these high currents, fault currents for 30 full cycles. And so that was an issue with the either the relay, I can't recall off the top of my head if it was a relay issue or a breaker issue, but that was one of the takeaways from that. And then also just the advanced notice of monitoring RMS transients getting worse and worse in severity and in frequency, prevalence, provided alert notification of the customer. And then recently we've launched a module whereby Wave IQ, our software platform, is ingesting live video feeds from thermal cameras and regular cameras and can detect, perform object detection. And we've trained the model to look for arcing and hotspots. And when our software sees them, it then commands our smart blocks in that area to, at the same time as the arc, capture the electrical signal. And so it may not be a breaker trip. However, we're able to correlate electrical signal distortion with arcing on the grid. And this is a prelude to detecting assets failing and tree branch issues, wildfire starting, and we're building our pre-trip event library at an accelerated rate now to where we can then have smart blocks and Wave IQ looking for these electrical signatures in areas where there's no video feeds at all. So we're training our platform in areas where we do have cameras with some customer participation. And then we're using that technology in areas where there's no video. So it's very exciting in our view.
Well, yeah, that is actually, and we'll add to that. I mean, it's, if you're able to detect, non-rotating type of equipment, failures like this, that's tremendous. Because a lot of these subs, a lot of distribution and generation, especially we're now getting into renewables, are all remote. You don't have anybody there. So being able to detect this stuff early that's a big benefit. So you don't, have unplanned downtime. You get out there and do an orderly shutdown as necessary. So again, it's really interesting that it's not just for rotating, that you're actually picking up all these other signatures, arc fault signatures, cable issues. So some of our friends, with solar and wind, they have lots and lots of underground cable. So I'm assuming, won't get into it too much, you see some of that, cable breakdowns, kind of like you showed with the conductor that was pinched earlier along those lines. So all this information starts showing up.
That's right. We actually launched this product line a few years ago, and initially into grid applications, delivery applications. And it was our customers really that pulled us into plant applications and rotating equipment and performing this frequency analysis. And it really just became a real sweet spot for us, not only delivery, but also generation and consumption. And so we're serving now several markets. And I think this is kind of like, turn it back over to you there, Evans, but really the ease of installation, especially where we can just connect to existing test switches or test blocks, then it's no wiring at all. If we're installing directly on a panel, then we'll still use our split core CTs, but then we use a voltage cable. and then to provide the visibility. And then one of the things of being online versus portable equipment, what we've learned, and we didn't realize the extent of the increased value, is that as an asset degrades over time, there will be days where it performs fine. It doesn't show evidence of degradation as it's getting worse. The next day it's now showing signs of degradation. So it's kind of getting worse and worse over time, but it will come back into compliance throughout. And so if you're using portable equipment only, many times you can get a false negative and thinking everything's fine, when in reality, an asset is actually degrading at a concerning rate.
Yeah, and what it really brought me into looking at this and the excitement of it is the ease to install. Again, being out in the industry and having to try to put these things in, some sort of wave capture, or either just a digital file recorder or actually a wave capture. It used to be a machine we used to have to take an outage on the motor. Well, now you can actually just go in there and do it. I mean, that's what, again, I'm just so excited about having something that easy and provide the information that it does. It's really come a long way. I'm really glad to see this product. This is really great.
And we're excited about it, that's for sure.
Yeah.
And so there's a picture of our device there on a panel, communicating with Wave IQ, and then providing access to the insight through the CertTrack portal. So we're real excited about, with the alliance we have with CertTrack. It's just provides just increased value to the industry.
Yeah, with the use of our portal, you can get it everywhere. And of course, our portal is a secure system. All of our stuff is an ISO 27001 review, and our information is in transit and at rest. All data is encrypted, so it's all easily accessible through our portal, but it's also very secure. So one thing about this picture too, I look at, we see the smart block, and the next thing over I see is a blue SEL relay. Really kind of the big difference between y'all's two is that yours is recording information all the time. The SEL doesn't necessarily record anything until it's triggered. So you're seeing continuous information, and that's why y'all are able to give the feedback on the predictive analytics, what's going on compared to the SEL stuff.
That's right. So we're monitoring the same signals as the relays are monitoring, the secondary voltages and currents. Our main focus is on predictive analytics. A side benefit, though, is capturing waveforms when a breaker trips as well. So it can provide a verification of relay performance, whether it be good or bad. The other aspect is there's a cyber benefit, and some of our customers, due to cyber concerns, and as many may be aware, relays, their main focus is to trip a breaker when it needs to be tripped due to safety. And so if anybody hacks into a relay, the concern is that potentially they could trip a breaker. And so if you disconnect a relay from a communication network, then nobody can hack into a relay and trip a breaker. Our device provides no control ability at all. We still provide the waveform when a breaker trips, so the engineers are not at a loss of any data. And then there's an enhanced security benefit in that, the platform is more cyber secure, and that the relay is disconnected from the network. So we have a number of customers that have physically disconnected relays from comms networks once they get the benefit of waveforms from our platform.
Yeah, which makes sense. I mean, this is real time. Your information coming across really is real time. So, and you're right. The isolation from a cybersecurity standpoint is enormous too. That you're not typing into something else that controls something. So it's a totally isolated system, and that's a huge cyber benefit. I see, Mike, you have your hand up, but if you would wait just a little bit, we'll hold on to your question. We'll let us finish up here, and we'll let you ask your question. And so if we get into, like we talked about, some of the items that we look at from a NERC compliance standpoint, what this can help us, the system, the smart blocks, and the recording capability and PRC2, if you're required to have a disturbance monitoring, like a sequence of events recorder, fault recorder, or actually dynamic disturbance recording requirements, PRC2, this device definitely would help you out with those particular recording and reporting information from PRC2, the NERC standards. Also helping would be VARs, just to have a secondary set of eyes kind of a thing, looking and helping make sure that generators stay where they need to be within voltage control. And that's required by transmission operators. Also can help transmission operators the same way. Of course, they also have stuff in place, but this is also a very good secondary backup to make sure that folks are handling their bar controls properly.
And then also, I just want to point out one more item on that, on the PRC2, or I think it might be PRC5, but where if the analog circuits are being redundantly monitored via relay as well as a platform like ours, then the standards allow for extending the test schedules on the relay. So it reduces O&M costs by being able to delay relay testing for a number of years if you have an alternate platform that's verifying the relays are accurate in terms of their voltage and current level monitoring.
So kind of going through it from our general conclusions, hopefully you are seeing the benefit of it. Definitely can improve your return on investment, having predictive analytics, knowing what's looking like it's going to happen before it actually happens. You can save on maintenance costs, production time, limit the damage. So there's a lot of ways that it can handle improving the ROI. Of course, enhancing reliability and visibility of your system is always a good thing. And it's not, you would not be there alone. We'd be there. Fish Block would be there to help watch the systems and help with whoever might want to go down this road to using this, and help interpreting that information, also notifications. And so here in just a little bit, we'll get into some questions, but our next steps will be, how can we help you utilize predictive analytics? Get with us, talk to us, and we'll move forward with you. And but here in just a sec, let's get into some questions, I guess. If you go to the next slide. So,
yeah, I'll just make one comment on that ROI.
Huh?
If you don't mind. Many of our customers actually get payback on the entire system within the first year.
Oh, that's really good.
Some of these outages are extremely costly, and unplanned asset failure. And if we're able to avoid even one or delay its or reduce restoration time, then it pays for itself inside 1 year. So that's our focus, actually trying to provide that to every one of our customers.
Yeah, that's the bottom line. Is the return on investment, and then also helping out with maintenance and preventing that if possible. I know, and I'm gonna look at one of our helpers here. If you would pull up questions, and then if we'll go one by the questions that were asked, but I'll also, since Mike's had his hand up for a little bit, I'll let you ask your question, Mike Ornish. See, you came off mute, but not hearing anything. Brandon, you get anything on that one?
No.
Okay. Mike, if you want to type it out, we can also go there and call it up in a minute. We're just not seeming to be able to hear you. Can you guys questions there?
Yeah.
Brandon, appreciate it. Pull those up.
So the first question from Lee is, on the pinion issue, did you find a bearing element / ball pass or cage pass frequency?
Question. It's information that we have in that file. I don't recall off the top of my head if there were any other frequency concerns with that particular asset. I know that we've on some of the sister assets in that project, we did see other frequency distortions that were out of the norm that we were later confirmed as bearing issues, bearing race problems, pitting, cavitation, and so forth. But on that one asset that had the pinion problem, I don't recall if there was any other frequencies out of the norm. We can certainly follow up with you with that information.
All right. So this next question is from Bill Martin. How sensitive is the instrumentation at picking up mechanical problems further removed from the electrical component? For example, is this monitoring equipment as sensitive as, say, vibration analysis at picking up a problem in an outboard pump bearing furthest removed from the monitor? Is this equipment sensitive enough to pick up a mechanical problem on a pump or fan that has a gearbox between the monitor and the driven component?
Right. The answer is yes. We have many of our customers and installations where vibration sensors are also used. And we're therefore able to correlate what our platform is seeing versus what the vibration scans are showing. And in nearly every instance that I can recall, if any issue that's been seen in the vibration profile has been correlated, and we also do see it in the electrical signal. And those are even cases where it's on the other side of the gearbox. And where vibration does have a bit of an advantage is, for example, if you've got two equivalent bearing types, both operating at the same frequency on the same shaft, say two ends of the same shaft, outboard shaft, our platform won't necessarily know is it the drive end or the non-drive end bearing, because they're both the same bearing style and operating the same frequency. So our platform will alert that there's an issue with the bearings, but they would both have to be inspected, whereby if you had a vibration sensor connected, or two vibration sensors, one on each bearing, likely then you would be able to see which one is the defective component. And so our solution is complementary to a vibration platform. However, if we had to choose which platform, we would be using ours, because we're picking up frequencies that are vibrating and causing electrical distortion. And then we pick up many failures that don't have any vibration characteristics associated at all. And so they don't show up in vibration plots, such as winding problems, for example.
All right. This question is from Andy. I believe, Greg, you already touched on this, but what is the sampling rate in hertz or per cycle of the smart block device?
Right. It's upwards of 128 samples per cycle. I won't spend a lot of time on this now because we already talked about it, but for rotating equipment and certain asset health monitoring applications, we vary that down quite a bit and extend the duration quite a bit as well to get higher resolution. And so it's a whole range. But if we're out on the grid and grid applications, purely looking at cap banks, breakers, lightning arresters, transformer health, we're pretty much at our highest sample rate all the time. And we're not continuously sending those waveforms to the server. That would bog down the communication networks. And that's the value of our smart block device in a lot of ways, that we have internal microprocessor that's performing all the analytics at the edge, only capturing the waveforms and sending them to the server when it's a condition of interest. And so it's like microprocessor based test switches or control panels rather than a relay.
All right. We got another question from Bill Martin. For the example of the arcing inside generator, did the maintenance team find the pinched cable during the initial inspection? Did they check alignment and find that it was satisfactory and continue searching for a problem? Or was the equipment restored to service following an alignment check and the signal still present, causing the site to look for other potential causes?
Great question. I don't recall if they actually checked alignment, but I do recall once they repaired that arcing cable that we no longer saw that signature. And so I'd have to check the file and can definitely follow up as to whether or not alignment was an issue or not. But the pinch cable definitely was was resolved.
Okay, here's another question from Andy. Can Wave IQ receive data from other sources beyond smart block devices, i.e. revenue meter or PQ monitor?
Right, yes. Our Wave IQ is primarily designed to work with smart blocks. However, our smart blocks are ComTrade, industry standard ComTrade and DNP3 format compatible. And so Wave IQ, therefore, and we do have some implementations where we're actually analyzing data feeds from third-party devices, whether it's PQ diff or ComTrade or DNP3 inputs. Yes, you don't need smart blocks to get the value from Wave IQ.
Okay, here's Mike's question. Some of what you highlighted, we are trying to address through information we can retrieve through meter data. How do you see this solution working with what we learn from meters? Is it two ways to do the same thing? Are they complementary? Is this preferred to meters? How do you think we should go about this?
Right. In my view, it's very complementary. The predictive analytics that's primarily being done with meter data, it's using, in many cases, what they call deep learning or neural networks, where you feed all of your meter data and any data you have, usage, weather, repair history, you feed all that data into a model, a deep learning model. Each of those variables ends up with, once the model learns from that, they each end up with their own weight, like a weighting for each variable. And there's various layers in that model so that those weights change throughout. And then the output is then the prediction of when the asset is likely to fail. And the accuracy of those models is only so high because there's only so much information. And typically it's limited to what the meters are monitoring, whereby our platform is looking at distortions in electrical signals that are indicative of degradation of subcomponents. And that insight can also be plugged into the deep learning neural network models as additional inputs. And it then provides a much higher accurate model because there's additional valuable data feeds that complement the meter data. And so we think it's very complementary. At the same time, if the meter data is from the same signals that our smart blocks are monitoring, we also provide the meter data. So the smart blocks not only are looking at high resolution waveform distortion, but also power and energy usage, and power delivery, energy usage, VARs. And so typically anything a meter is doing, our smart blocks are doing as well. And so you don't need two devices unless you're using meter data at a different point in the circuit, maybe at a customer site where the smart blocks are at a local substation. Then both of those can be fed into a predictive analytics model, as I said, and to provide the highest chance for the highest prediction accuracy, which is what we're going for.
All right, I think that's all of our questions in the chat for right now.
Okay. Well, I do appreciate all the questions, and I do appreciate our time here with Greg and that he's been able to provide us. I mean, I really am excited about this. I don't show it a whole lot, but it really is a very good product, a very useful product. And like I said, I wish it was around when I was developing and having to put in, figure out what's going on the grid, or in a plant. So very, very useful tool. So do again, appreciate your time, Greg. If there's no more questions, like I said, move on. Anything else, Greg?
No, that's all I have. I really appreciate the opportunity and all the interest and the participants and the questions. Look forward to follow up. We provide webinars. If you contact, there's I think a link somewhere to click on to sign up for a custom webinar. We can actually walk through the platform, show you the dashboards and how it all works and how it can provide value to a specific application, we'd be happy to do that. So thank you. I appreciate it.
Thank y'all.
There's the link.